So we have more continued probability here. We're going to introduce the idea of two-way tables and independence and association. So we have some data here. Study the ages of long-distance runners in a certain country produced the following results, as they're shown in the table. But you can see that the data is actually incomplete. So what we're going to need to do is go through and see if we can kind of puzzle this together ourselves, knowing that each column has to have a total, each row has to have a total, and then down in the bottom right-hand corner, we have the entire table total as well. So we're going to use these values to try to help us out. So if we take a look at this, I think I'm going to go ahead and take a look at this row of males. We do see that the total here is going to have to be 100, which means both the middle-aged and the elderly are going to have to give us a total of 100. Well, if 75 is already accounted for, then we know this missing value for elderly is going to have to be 25 to be able to get the 100. So I'm just going to try to fill this table in as best we can. I'm going to do the same thing with the females here. Notice that in order to get the 45 total, we already have 15. So it looks like that empty part is going to have to be 30 to be able to get that. Do a quick check when you fill something in and make sure that the column actually works. If it doesn't, you made a mistake somewhere. So in this case, we know the 75 and the 30 do give us 105, so that one's good. And we can then take a look at the elderly column. Well, we know the two entries now for male and female, so we should be able to figure out the total here, and 25 plus 15 is going to give us 40. That wasn't the only way we could have done this. We could have actually figured out this total. So remember, this whole table total at the bottom. If we add the 105 and the 40 together, we have to get 145. Additionally, we can take a look at that column and do 100 plus 45. We have to get 145. Okay, so it looks like our table is complete. Now we just need to be able to answer some questions. So the probability of male, so we're going to take a look at this. The probability of male is going to give us this last value of 100 out of the total of 145. So I think we are going to have probability of male is going to be 100 out of 145, which we can simplify or we can turn into a decimal or a percent. Probability of elderly, we're going to take a look at that column of elderly. We have a total of 45 out of 145 total people in this information that's given to us. So we have 40 out of 145. Okay, and then continuing on, we have male and middle-aged. Okay, so we want to figure out where male and middle-aged actually collides. Well, male and middle-aged, that's going to give us that 75 right there out of a total of 145 people. So we're going to do 75 out of 145. Again, can be simplified. Write it as a decimal, simplified fraction. Fraction simplified or decimal or percent. You can even leave it as 75 over 145. Okay, continuing on with the information that we have, we'll go ahead and fill in the table that we did previously and see if we can answer the following questions. So continuing on with probability of female or middle-aged. Okay, so that means being this female, 45 total, or middle-aged, 105 total. But remember with or, we want to make sure that we get rid of anything where there is an overlap. So this 30 actually is going to be getting double counted. So we just got to be careful with this. So if we go through, do the probability of female, or, so plus, probability of middle-aged, so that's our rows and columns that we're interested in. But then because there is an intersection between these two, we're going to have to get rid of that, only because we don't want it double counted. So female and middle-aged. Okay, so probability of female, where there are 45 total female out of 145 total people, plus probability of middle age, there's 105 total middle-aged out of 145 people. But then remember, we've got that overlap that's been double counted. So middle-aged and female is going to be that 30 out of 145. What's nice about this is that our denominator is already the same, so we can keep the 145, and then we're just going to do the math on the top. So if we add the 45 and the 105, we're going to get 150, and then 150 minus 30 is going to give us 120. Remember, probability needs to be between 0 and 1. Could be 0, which means it's not going to happen at all. Could be 1, it's 100%, means it's going to happen all the time. We don't want probabilities. Well, there's no such thing as a probability that's going to be larger than 1 or less than 0. Okay, so now we have probability of elderly given male. All right, so our population, our subpopulation we care about is the probability of being male. And then we want to know the intersection of elderly and male. So we can treat these as probabilities or we can treat these as counts. I'm going to go ahead and treat it as probability for the time being so we can see what the fractions actually do. So the probability of male in our table, where there's 100 male out of 145 total people. And then we're talking specifically about elderly and male. Well, elderly and male is 25 out of 145. If we were to go through and simplify this, we know that when we divide by a fraction, you actually multiply by the reciprocal. Something beautiful happens here. Since these denominators on the fractions are actually the same, when you multiply by the reciprocal of the bottom, those 145s cancel. So what we end up with is 25 out of 100, which we could simplify if we'd like. Again, we don't have to. Are being middle-aged and female independent events? Well, independent events means that there is the probability of those two events or the intersection of those events compared to the probability of one of those events are exactly the same. Or the probability of one of the events is going to be exactly the same as the probability of an event occurring given something else has already happened. So we have a couple of different ways to do this. So I'm going to do the probability of middle-aged, just trying to figure out a comparison. We're trying to determine, is that actually equal to probability of middle-aged given that the person is female? So if these are independent events, then that means these two probabilities are going to be exactly the same. So breaking it down into a subgroup of female and then only looking at middle-aged within the female group will have zero bearing on the probability of just being middle-aged. If that's the case, then these two events are independent. If it's not, it means they're not independent. Some sort of an association going on. So let's take a look. Probability of middle-aged. Well, probability of middle-aged, we have a total of 105 middle-aged out of 145. So this is 105 out of 145. Conditional probability. Remember, we are going to break this up into a subgroup. We are going to, so our subpopulation here is going to be female. So we know this person is going to be female based off of the comparison that we're doing. And then of that group of females, we want to see how many of them are in the middle-aged group. So we're going to do middle-aged intersected with, so and female. Now I'm going to do this as counts this time. We already took a look at the probabilities and then the denominators canceling if they matched. So I am now going to do this as counts. So how many total females? Well, the number of total females is 45. So that's my new subpopulation here. Now, of those 45 females, so going back up to my table, of those 45 females, how many are middle-aged? Well, that's going to be 30. Knowing that my denominators of 145 on both of those are going to cancel. So now, I don't really know if these are the same. So I am going to type these in and figure out if these two decimals are equivalent to each other. And they have to be exactly the same. So if we type that one in, and then if we type the other one in, oh, looks like they're not exactly the same. So I'm going to say not exactly the same. Since they're not exactly the same, and we're asked if these are independent events, that's the question. If they're independent, then those would have been identical. So what we can say is that being middle-aged and female are not independent events. And as a reminder, if events are not independent, then we would say yes, there is an association between them. Now, we don't know if it's any type of cause and effect. We just know that there is some sort of an association between the two events.